Welcome back to Further Solutions Academy. Further Solutions Academy. I encourage us more to share our video and also subscribe. If you have not subscribed before, kindly press your subscribe button for direct updates. At this point, we have a lot of videos, close to 400 videos. It means you can come here and learn any topic of your choice: mathematics, physics, and chemistry. You can comment below, or you make use of this line to reach us. Now, you can do three things with this line. You can call us, you can WhatsApp us, and also via Telegram is allowed, either of the three. Now, either of the three, you can do that. On this video, I'll be walking you on conservation of linear momentum. Now, I've done pause, momentum, and force apply. Please make sure you check on our previous video for more understanding. Now, on this video, I'll be working on the conservation of linear momentum and other things. Now, when we talk about linear momentum, now you have to understand what is called we are combining the Newton's law. I think I've stated the Newton's law in the previous video: first, second, and third Newton's law. It means this time around we are combining second and third Newton's law, which is to result in the law of conservation of linear momentum, which states that when two or more bodies act upon one another, their total momentum remains constant, provided no external forces are acting. Momentum, velocity, velocity and kinetic energy of colliding bodies are calculated, which is we got to calculate it in that form. Now, please take note of that. If you are talking about linear momentum, number one, we are talking about two bodies. Very, very important. I think in my previous video, I've explained impulse, I've explained momentum, and I've also explained force applied. Please take note of those things. They are very, very important to this video, because I won't have the time to be. I have a lot of things to cover up as far as this video is concerned. Now, let me try to show one or two examples so that you will be able to see what I'm trying to explain here. Try to see what I'm explaining here. Now, look at this particular part of look at this. Okay, look at this problem. It was sent to me from one of my friends. Okay, an object of mass 5 kg move with a velocity of 12 meters per second due north. It's a stationary body of mass 7 kg. If they are stick together after collision and move with velocity v due north, calculate the magnitude of v. Now, let's try to work on this question. I think by this you will be able to understand one or two things. The first thing you need to understand, we are talking about what? M. There are two M. I can call it M1 and M2. Now, the M1, which is the mass, is equals to what? 5 kg, which is going to be 5.0 kg. And the second M, which are stationary, it's a stationary body of mass, which is going to be mass. It means this one is weight, just standing somewhere. Okay, I have the velocity now with a velocity. It means my v1 will be equals to 12 meters per second, and my v2, which is going to be final of this thing, which will be the final, will be 0 meters per second. Please don't forget that. Now I'm working on mass of this and this. What I need just to do, I will take the momentum before collision and momentum after collision. Now, my momentum before collision, it means momentum before collision equals to momentum after collision. Now, that is what I'm going to work on. Since I can get something like this, it means before collision will be M1 V1 plus M2 V2 equal to M1 plus M2 bracket of the V we don't know, which is going to be the V do not. Now, that is what you just need to do. Now, since I have that, I have my M1 as 5 multiplied by 12 plus this one will automatically become a 0 because 7 times this will become a 0. I'm going to waste my marker. Now, this one will be M1 is going to be 5 plus M2, which is 7 bracket of V. I don't know it. Now, since I have this, I can now say that what this multiplied by this, it will be 60 equals to this one will be 12, which will be 12 V. Divide this out by 12, my velocity will be equals to, that is my velocity. That is all what I need to do. By so doing that, I've gotten my what? My answer, which I don't need to stress myself longer. That is all what I need. Can you see it's very, very, just note that what? Momentum before and momentum after. By so doing that and you go. That is all about that. If you don't understand momentum very well, please try as much as possible to check on our previous video because I'll break down everything you need about momentum there. Okay, see another example for more explanation on this. Okay, I need to rub this because of space. Now, look at this problem also. Now, look at this. It's a very nice question that anybody can ask you somewhere. A tractor of mass 5.0 multiplied by 10 raised to the power 3 kg. Please notice that it must be in kg. Please take note. If not, you need to convert. Is used to tow a car of mass 2.5 multiplied by 10 raised to the power 3 kg. The tractor moved with a speed of 3.0 meters per second just before the towing rope become taut. Calculate the 1. Speed of the tractor immediately the rope becomes taut. 2. Loss in kinetic of the system just after the car has started moving. And 3. Impulse in the rope when it jack the car into moving. Now, these are the things I need to explain. Jack the car into motion. Sorry, let me just move it. Motion. I make mistake there. Motion. Now, these are the things I want to work on. Let's try to solve this and see how it will go. Now, it's a very simple question. The first thing you need to know, you need to understand what are the things available, the apparatus. The first one, I'm talking about mass of the tractor, which is mass of the tractor will be equals to 5.0 times multiplied by 10 raised to the power 3. Now, that is very first thing. And the second one, I will be talking about the velocity of that tractor. It has its velocity, which is going to be what? Let me call it U1. It will be equals to, okay, very, very nice. Now, since I have that, it means my U2 will definitely be is 0, which is going to be the final of the velocity. Meaning, yes, that's going to be the final velocity. Now, I also add the mass of the car. Mass of the car, it will be 2.5 multiplied by 10 raised to the power 3 kg. Please, this is very important. Now, since I have this, let me use V. Let V be the common, let's say the common velocity, which is common velocity. Now, It means let my V be a common velocity, both tractor and the car, which that is what we have to take the moment on. Now, for me to get this, it means I'll move on to number 1. The speed of the tractor, immediately the rope becomes taut. Now, it means I will take the momentum before and after. Momentum before movement, and momentum after movement. Now, please take note of this. It means I want to take the momentum around. Now, since I have this, it means I'll be talking about M1, V1 plus M2, which is, I'll be talking about, let me just put M1, M2, please, for better understanding. M1, M2. Now, M1, M2, it means mass of the tractor and U1 and M2, U2, which is equals to M1 plus M2 bracket of the velocity we are referring to. Now, it means I will be talking about, by so doing this, I'll be having multiplied by 0 times 10 raised to the power 3 plus, multiplied by, and this one will be 3, which is going to be multiplied by 3 plus 2.5 multiplied by 0, which is going to be multiplied by 10 raised to the power 3 multiplied by 0 plus. Now, the next thing I want to work on is to be 5.0 multiplied by 10 raised to the power 3 plus 2.5 multiplied by 10 raised to the power 3 bracket of, okay, sorry, this will be equals to, I make a mistake, bracket of V. Hope I'm not making any mistake. Yes, no. Now, this one will definitely become 0. Now, I have this, which I'll be having, this times 3 to be 15. 1.5, 10 raised to the power 4 equals to, this and that will be equals to, normally, it will be 7.5. 7.5, 10 raised to power 3. Yes, this plus this. Yes. Okay, since I have that, which I'll be having now, it means indirectly I'll be talking about 7,500 anyway. Now, it means my V, with my V will be equals to 1,000, which is, this one will be definitely be equals to 15,000, I think. It will be 15,000 divided by 7,500, which it will be equals to 2 meters per second. That is it means this is 2 meters per second. Please take note of that. 2 meters per second. Please, this what we are talking about is 2 meters per second. Permit me, because the space is not enough. We need your support at this point. We need to buy a bigger board so that we can be able to, play around with the board. Now, that is the first one, which is 2 meters per second. The loss, we're talking about the loss of kinetic. Loss in kinetic energy will be equals to final kinetic energy minus initial kinetic energy. That is how to find loss of kinetic energy. Now, I want to know that my kinetic energy is always equals to 1/2 mv squared. Please take note of that. This is my kinetic energy formula, which is with that formula I can say that normally I have this and this. It means my final velocity, I mean initial velocity, I mean kinetic energy will be equals to kinetic energy of the moving tractor. Now, which it will be equals to 1/2 m1 v squared. This u squared is not, sorry, I'm not using v, I'm using u squared. Now, since I have that, it means I'll be having 1/2 multiplied by 5.0 multiplied by 10 raised to power 3 multiplied by 3 squared will be equals to, if I should press, it will be 2.25 10 raised to power 4 joule. 10 raised to power 4 joule. Now I have that. I can now talk about the final kinetic energy, which will be equals to kinetic energy of the moving tractor and car. Now, don't forget that we have sorted out that it means at that point I'll be talking about 1/, it will be bracket of m1 plus m2 bracket of v squared, which is going to be what? Which implies 1/2 bracket of 5.0 10 raised to power 3 plus 2.5 10 raised to power 3 bracket of what of my v, and my v is known as 2 squared, which by so doing this, I think by so doing this I will be having now by so doing this I need to do some things. Hope I'm making mistake. Hope you know I'm making mistake. Now it means I'll be talking about 1/2 7,500 4, which it will be equals to 2 here, which will be 15,000, because here will be 1, here will be 2. 2 times 6 is 15. Now, which I can as well write this as 1.5 10 raised to power 4 joule. That is the kinetic I'm talking about. Now, I can answer that what lost in kinetic energy will be equals to 1.5 10 raised to power 4 minus 2.25 multiplied by 10 raised to power 4. Now, if I should do this together, we are talking about 15,000. Okay, 1 2 3 4 1 2 3 4. Okay, which it will be equals to, here will be 15,000 minus, we have 22400, which is 22,500, which it will surely be equals to loss in kinetic energy will be equals to minus 7,500 joule. Now, you can see that is a minus. Why is it minus? Because, number one, because you have to know that we are talking loss in kinetic. It means it will be negative. That minus indicate that what is lost in kinetic. That is what I need to understand that. Now, with that, you understand your impulse. Before I end this, let me quickly explain the third part of the question, which is, this is kinetic, loss in kinetic. Now, let me quickly explain the part one, which is going to be the last part of it, which is impulse. Now, impulse is equals to change in momentum. Change the momentum. Now, to get my momentum, I'm talking about final momentum. Final momentum minus initial momentum. Now, what is my final momentum? My final momentum is m1 plus m2 bracket of v, which is minus m1 v1 plus m2 v2 u2 rather. Let me use a u. This is going to be u. This is u, because this one is all about tractor. Now, definitely, this will surely give me 0 because of what? We are talking about 0 meter per second. It means I'm talking about 7,500 multiplied by 2 minus 5.10 power 4, which is going to be 15. Yes. Now, by so doing this, I will be having. Now, by so doing this, let me try to do this. Which is going to be 15. This is going to be 15. I have 15,000 minus 15,000. Yes. Which is going to be 0 Newton seconds. 0 Newton seconds. Or you can put it as 0 kilometer meter per second. Either of the two. That is what we mean by what? By that. Per second square. Yes, per second square. Now, that is all what we need for that. Now, you can see that is all we need to do. I have to stop here because of my time. In the next video, I'll be talking about recoil of the gun and other part of it. You know, oh, don't forget you are home with Further Solutions Academy. Once again, thanks for watching.